Hi everyone, okay, we are going to talk about functions and graphs today, and it will be on sketching the graph of y equals to fx over gx, alright? So there are 4 things that you will need to look for, okay, that you will need to find in order to sketch the graph of y equals to fx over gx, and they are the x-intercept, the y-intercept, the turning point, and also the asymptotes, alright? So before we look for any of these, okay, you have to check and see whether the algebraic fraction given to you, fx over gx, is a proper or an improper algebraic fraction. So if it is improper, you have to perform long division. Okay, so let me first tell you how do you decide on whether it is a proper or an improper. Let's look at the 3 examples that I have laid out on the board. Okay, the first one says y equals to x over x plus 3 x minus 3. If you were to expand the denominator, that is when you will see x over x squared minus 9. This is what I call a proper fraction. And why is it a proper algebraic fraction? Is because the highest power of your numerator is 1 and the highest power of your denominator is 2, hence it is 1 over 2, a proper fraction. Second, you have y equals to x minus 4 over x minus 2, and I call this the improper fraction. Why is it improper? Is because numerator has got the highest power of 1, denominator has got the highest power of 1, when it is the same power on top and bottom, that is when you call it improper fraction, hence long division is necessary to rewrite a fraction into another form. Okay, right, so how do I perform long division? Numerator x minus 4 is to be put as your dividend, okay, you put it inside your division, okay, and when you have your x minus 2 to be denominator, that should be taken as your divisor. Perform long division in such a way that you have got your x here, your x there, decide on what to multiply with x in order to get an x over here, hence it should be 1. 1 multiplied by x minus 2 will get you x minus 2, you minus accordingly, that is when you will see a remainder of negative 2. There is no need to divide further because negative 2 has got a lower degree as compared to your divisor x minus 2. Yeah? So how do you rewrite your expression x minus 4 over x minus 2? Quotient is to be put in front, and quotient for this case is 1. Remainder negative 2 is to be put over here, and your divisor x minus 2 is to be put there. Hence, y equals to x minus 4 over x minus 2. It's equivalent to 1 minus 2 over x minus 2. Alright, and what about for the third example? You have got y equals to x squared minus 4 divided by x minus 1. Obviously, this is an improper. Why? Because the highest power of your numerator is 2 and the highest power of your denominator is 1. 2 over 1, it is for sure an improper. Hence, a long division is necessary. X squared minus 4 I put at the bottom, okay, that will give you a dividend. X minus 1 is your divisor. How do you divide, okay, how do you multiply, what are you supposed to multiply with x in order to get an x squared? You're supposed to have an x to be multiplied, so x times x, you will get x squared. X times negative 1, you get negative x. Subtract accordingly, minus accordingly, that is when you will see x minus 4. Can it be divided further? Of course can, because it is x minus 4 over here, x minus 1 over there, it is still improper in a way, hence I'm going to have a plus 1. 1 multiplied by x minus 1, I'm going to have x minus 1. When you subtract accordingly, that is when you will get a remainder of negative 3. Right? So how do I rewrite this algebraic fraction? It should be written as, again, quotient is to be placed in front, x plus 1, and remainder negative 3, divisor x minus 1. Why is there a need to rewrite your algebraic fraction? Is because it will be simpler for you to look for asymptotes then. Imagine having it in such a form. It is difficult for you to tell exactly what are your asymptotes. Yeah? So moving on, let's look at how you can actually look for asymptotes. Okay? Take note of this one. When you have y equals to a over x minus p plus q, note that x and y are variables. A, P, and Q are numbers, okay? They are real values, alright? So what would the asymptotes be if this is what given to you? We all know that if x is equals to P, this whole function will be invalid, yeah? Because we cannot have denominator to be 0. So what then should I say about my asymptote? X equals to P is my asymptote, because asymptote simply means a point or a line that you will never cut, okay? It is a line that you will never cut. So x cannot be P, hence x equals to P is my asymptote. Always leave your asymptote as an equation, right? So if a over x minus P is never 0, that is when you will say that y, it's never q. Am I making sense to you? This fraction is never 0 because a is a value, hence it is never 0. Okay, a value that is not 0, a is a value that is not 0, hence this a over x minus p is never 0. The moment this is never 0, y is never q, and that makes it your asymptote, y equals to q. Alright, so if you have got this one, okay, let's look at the 3 examples earlier and let's tell the asymptotes. Alright, example 1, okay, I have got this form, yeah. So x equals to negative 3 is my asymptote, x equals to 3 is my asymptote, and one thing to note, y equals to 0 is another asymptote. And when do I have this y equals to 0 as my asymptote? When you have a proper fraction. Why y equals to 0 is an asymptote? Because again, like what I explained to you earlier, the moment you have got this fraction to be non-zero, that is when y cannot be 0. Okay, so note that when it is a proper fraction that you are dealing with, y equals to 0 is always one of the asymptotes. Right? What about for this one? Okay, based on what I've told you, we always take our vertical asymptote at the bottom, and it is always this number that we take as our horizontal asymptote. Hence, if you were to look at this, x equals to 2 will be my vertical asymptote, and y equals to 1 will be my horizontal asymptote. Okay, and what about for the last one? We have got y equals to x plus 1 minus 3 over x minus 1. Vertical asymptote will definitely be x equals to 1. What about your horizontal asymptote? For this case, they wouldn't be horizontal asymptote. Instead, you will get an oblique asymptote because y is equals to x plus 1. Okay, so it is an oblique asymptote. Do not be afraid of the word oblique. Oblique simply means slanted, hence you're going to have a slanted asymptote. Alright, but oblique asymptote is a nicer term, okay, for such an asymptote. Alright, so let's look at a few examples. Okay, in this video, I'll be talking about the first example. In the next video, you're going to see example 2 and example 3 explained to you, and I'll be adding 2 more examples for you to understand thoroughly on this part of functions and sketching graphs. Yeah. So example 1 was y equals to x over x plus 3x minus 3. Yeah. So x asymptote, x-intercept. How do I look for x-intercept? X-intercept is found when y is equals to 0. So the moment I put a 0 here, that is when I'll get x equals to 0. Hence 0, 0 is my x-intercept. What about y-intercept? Y-intercept simply say x is equals to 0. Hence I'm going to put 0 here, 0 here, 0 there. That is when you will see y equals to 0 again. Hence it is again 0, 0 to give your y-intercept. What about for your turning point? To look for turning point, I would strongly suggest that you use your CAS calculator to perform differentiation. If not, for questions that are simple, you can work on your own y prime. So I work on my own y prime, and from here I could see that y prime is never 0. And why is y prime never 0 is because for y prime to be 0, I should have negative x squared minus 9 to be 0. But x squared can never be negative 9. Therefore, y prime is never 0. And the moment y prime cannot be 0, that is when you say there is no turning point. Okay? And what about for asymptotes? We have worked on that earlier. It is x equals to 3, x equals to negative 3, and y equals to 0. So how then do I sketch my graph? Start with asymptotes. Yeah? Start with x equals to negative 3, a vertical asymptote. Then go with x equals to 3, another vertical asymptote. Y equals to 0, your horizontal asymptote. And plot your intercept if there is. For this case, yes, there is 1. I have got my x and y intercept to be here at 0, 0. And also if there is turning point, plot it accordingly. But for this case, there is no turning point. So how do I tell the shape, okay, of my graph? Okay, you can always test it out by putting a random value. For x more than 3, it could be a 4. So if it is a 4 that I plug, this a 4 here, which is a positive. 4 plus 3 is still a positive. 4 minus 3 is still a positive. A positive divided by a positive would give me a positive y. Hence, I know I must have an arm here. And note that for graphs like that, you always have it at what do we call opposite quadrant. So it is always first third or second fourth. Yeah. So if it is first that I've put the next would be third. Yeah, and since there is no turning point, hence this is a point of inflection, so I should have drawn something like that. So if it is a first again, it must be a third there. Okay, so that is how you decide on where to put your curves. Alright, so that is about the first example.